Okay, good afternoon, everyone, and welcome to this special event today. I'd like to welcome special friends from Nigeria with us today, and uncounted for, but they're with us. I think before we start, I just want to say 2 words about this event today, and the aim and why we want to have it. Then I will present our speaker, then I will present the panel, people that will participate together with the speaker in a discussion that follows his speech. You probably have heard about ENSUS, the Energy Sustainability Chair. I think it's been around for a little bit over a year. And it's the vision of the chair is really to work on different aspects of the energy sector, in particular education, entrepreneurship, and research. It was established in March 2021 by OCP and UM6P. It's hosted at UM6P at the MSN department today. And it seeks, again, to bridge the academia and industry in Morocco and in the region. So it's a platform, really it's a platform. Its definition is not like what you would be thinking about, like a department or a school or something. It's actually quite different. It's more of a platform to share, exchange, learn, and disseminate. We decided that one of the actions that the chair will be having is to have a monthly meeting with world experts in his field, in the energy, of course, sector, to share the latest trends and insights in the energy transition, related sciences and technologies. We have 5 different topics that might come up at any one particular meeting, and those 5 topics are energy storage, solar energy, hydrogen, carbon capture and utilization, and water energy nexus. Okay. So each lecture, as I mentioned, we'll have a panel discussion afterwards. And during that panel discussion, we will ask the panelists certain questions, and then we will open for the public to ask questions, and we will assemble all of these things. The lecture plus the questions, we will edit them, of course, and the answers, we will edit that, and that will be one file. And after 6 months, we put all these files together, and we will issue a book. And this book will be ENSUS Discussions Edition 1, ENSUS Discussion Edition 2, and so on. So with that, please feel free to ask your questions once the time has come, and we're looking forward to having a nice discussion. So our speaker today is Dr. Jawad Kharraz. He is the Executive Director of the Regional Center for Renewable Energy and Energy Efficiency. He has been working as a senior expert, advisor and evaluator for several international institutions and boards. For example, the European Commission, the EU GCC CETN, I don't know what that stands for, but could really tell us about that. And member of the IDA, European Desalination Society. He also at Oman Energy Majlis. Dr. Kharraz has been director of the research at the Middle East Desalination Research Center in Oman between 2015 and 2020. The panelist today is Dr. Mohammed Shakir Nasibi, sitting over there. Dr. Mohammed Shakir Nasibi is a professor researcher at UM6B. At UM6B's International Water Research Institute, with research interests in the design, optimization, and development of sustainable technologies and processes for water treatment based on circular economy principles. And then we have Dr. Maed Debi next to him. He's an associate professor at the Material Science, Energy, and Nano-engineering department at Mohammed VI Polytechnic University in Morocco. He's also the editor of Scientific African Journal, etc. Just before I give the word to Dr. Kharraz, I just want you to be aware of this first issue of the ENSUS magazine that is possible to download today. Here's the address, ensus.um6b.ma publications, where Dr. Kharraz is actually the head or the main face of the journal for this edition. We have an interview with him on the subject of desalination and water energy nexus. Okay, so I already talked about that. So with that, I would like to welcome Dr. Kharraz very warmly to give us this presentation.
Thank you very much, Dr. Yunus. Good afternoon, everyone. Thanks for coming. Thanks for having me. Thanks, special thanks to Dr. Yunus, Dr. Mohammed Nasib, Mohammed Shakir, Dr. Maad, and Amal for having me today. So, as Dr. Yunus mentioned, I'm the Executive Director of the Regional Center for Renewable Energy and Energy Efficiency, RECRE. It's based in Cairo, Egypt. In my career, I've been working for long years in the water sector, and then the energy, desalination. So, as you know, water and energy very interconnected. That's why the topic of today is water energy nexus. The water energy nexus explains a little bit the interlinkage between water and energy, and how can we better manage water resources in an efficient way. So, just wanted to clarify. I mean, I was a consultant at EU Energy Network, which is a European project for the Gulf countries. It's about promoting clean energy in the Gulf countries, and it's a collaboration between the European Commission and the Gulf countries. So the topic of my presentation is the water energy nexus, challenges, solutions, and perspectives. I was given, I think, 1 hour, but I hope we'll make it less than 1 hour. And I hope that it will not be boring. I will have more, many questions, hopefully, from you. Briefly, the outline. So I'm going to explain a little bit what we do in RECRE, what is RECRE, and then I will go into the topic, what is the water energy nexus, some examples, challenges, in particular, the energy demand in the water and desalination in particular. So desalination is the clear example of the Nexus. And then I will go a little bit into desalination, renewable desalination, and then I will give some perspective recommendations. RECRE, so we are sort of intergovernmental organization. We have 17 Arab countries on board. We're also the technical arm of the League of Arab States, Energy Department, all what's related to renewable energy and energy efficiency. We are leader in clean energy, policy dialogue, strategies, technologies, capacity development, investments, and project support. We are based in Cairo, as I mentioned it, and we have representatives in all the ministries of energy in our countries. The main work areas are clear, so we do support policy reform in our countries. In particular, we develop action plans for sustainable energy. We support legal, regulatory, and contractual frameworks in our countries. Knowledge management, we develop research and also data management. We have an online platform called taqaway.net, and we develop every year one indicator called AFEX, Arab Future Energy Index. So somehow we assess the progress of our countries vis-a-vis the renewable energy and energy efficiency. One mandate also we have is to promote the investment of private sector and the renewable energy and energy efficiency. So we have many activities in this area. We do assess the market. We promote investment in different ways. Also, we work a lot on financial and technical assessments, social and economic impact assessment as well of the different renewable energy projects. In climate change, we have an environmental unit since 3 years ago, so we do a lot of work in that. For example, we have what we call indice tracking tool, so we assess the progress of our countries vis-a-vis the mitigation measures, vis-a-vis the Paris Agreement. And finally, we have some specified programs and standardization, like solar heater, etc. So briefly, as I mentioned, we do a lot of work in policy reform and regional programs. We developed together with the League of Arab States the Pan-Arab Sustainable Energy Strategy. Then we have some tools to implement it, what we call the Arab Energy Efficiency Guideline, Arab Renewable Energy Framework. And we have what we call planning tools like National Energy Efficiency Action Plan and National Renewable Energy Action Plan. And we have some reporting tools periodically. Just a sample of project we have. So MIFMED is the European Commission project. So we have partners in 8 our countries, plus some other countries from the European side. It's basically about energy efficiency in building and appliances. We do, as I said, lots of work in promoting private investment. Just an example of report that we develop in different Arab countries to promote investment in renewable energy in particular. In research and analysis, as I mentioned, we have the AFEX, which is the Arab Future Energy Index. We develop it every year. So we one about renewable energy and one about energy efficiency. And as you can see in this, for example, this example of AFEX, Morocco is doing well in terms of renewable energy, the first in the Arab region, followed by Jordan, Egypt, etc. Standardization and certification. So we have some like CEMP, which is Certified Energy Management Program, it's a very popular program. And we have some like solar heating, which is standardized solar heater that we promote also in the region. In terms of financing also, we work a lot with EBRD, EIB, we work with UNIDO, and in particular we have an interesting project with about bird migration protection. So in the Suez area in Egypt, is very known by the migratory birds that pass by in March and October, and there are lots of investments in wind energy. So we have now more than 2 gigawatt there. So obviously, as far as we have more turbines, so there are more fatalities in birds. So our role is to protect the birds. So in a way that we have teams in situ, they monitor the birds and they alert the companies to shut down the turbines in case it is a risk. So this is just an example of the project that we have with private sector. So now I will go directly to the topic. So as you know, in terms of water scarcity worldwide, if you can look at this map that represents the water risk worldwide, we can see clearly that the MENA region, including Morocco, is the area with the most of risk in terms of water scarcity. We can have many indicators. We could talk about water scarcity, water security, water stress, etc. But all these kind of indicators clearly show that Morocco and MENA region are the areas of most risk in terms of water scarcity. Water security as well. So as you can see, so always the red color is in the Arab region, in Morocco including, and many other regions around the world. So we have the water security issue, but also we have the energy security issue. So the International Energy Association predict that the global economy will require at least 40% more energy by 2030. So this is huge. Currently, 1.4 billion people don't have enough electricity. And we have an estimation of like by 2030, 1.2 billion people will still have not have access to electricity. So this is huge. So there is a huge effort to do in terms of access to energy. And food security as well. So we usually talk about water, energy, food nexus, because not only water, energy, but also food. So we need water for crops, and also, I mean, we need the energy to transport food, etc. So also, if we look at the map in terms of forecasting by 2030, the FEL forecasts that there will be an increase of 50% of demand in terms of food. So what does the future hold? If we look at the picture, so what we have a water security issue, energy security issue, and food security issue. So water security, we can, for example, the example of Egypt, as you know, with the Renaissance Dam of Ethiopia, there's a huge risk that Egypt will get less and less water. So that's why from now they're starting planning many desalination plants in the Red Sea and the Mediterranean seashores. And so this is really an alarming situation. Energy security, so as I mentioned earlier, so also there is a risk, obviously, and so also desalination, for example, it consumes a lot of energy, so it could impact the energy in some countries. Apart from the environmental impact, greenhouse gas emissions, so we need to commit to the Paris Agreement in a way to reduce the emissions. And food security, so 60% of food from irrigated agriculture in some areas, fossil groundwater is being exploited. So even in Morocco, in the south, in Zabura, for example, we have a problem because a lot of over-exploitation of the aquifer, the groundwater, and there is a problem. So we need to find solutions. As you know, global challenges need scientific and political solutions. Not only scientific, so we need science and innovation to find solutions, but also if there is no political will, things will not advance. So in many areas, if you look at the increasing water scarcity, the threat of viruses, etc., the growth of developing nations, the rising cost of energy, the new stringent regulation sometimes, and massive infrastructure needs. So all these challenges require from us a huge effort scientifically and politically as well. So what is the water, energy, and food nexus? So the water, energy, food nexus, simply, it explains the interlinkage between the three sectors, and adopting the nexus approach is we're trying to improve the efficiency of each one of the three without being in the expense of another one. It means that, for example, if we improve the water efficiency, for example, shouldn't be in the expense of the energy. So, for example, I try to use to improve the water efficiency, but I use more energy. So this is not the in the nexus. We need to have the efficiency of the three at the same time. So in terms of society, so we have obviously issues of population, urbanization, also culture, some other issues. So for example, some farmers in Jordan, Jordan is one of the poorest countries in terms of water worldwide. So some farmers used to cultivate some crops that consume a lot of water. And if the government tells them that you stop, you need to change the crops, for example, change the tomatoes, I don't know, another crop which consumes a lot of water, people will accept because it's somehow Jordanian have a tribal society, and people have, tribal are very strong. So they say we cannot change our culture. So we have been for decades cultivating this crop. We will not change, between day and night. The same problem of groundwater. For example, if there is even regulation, let's say I tell you stop using groundwater, and some still in drill wells, and they say you need water. So it's difficult sometimes to enforce the regulations. So in terms of technology, so we have a new development, a breakthrough potential. So as you know, desalination, for example, there are many now innovations in terms of technology, also in terms of wastewater treatment, reuse, etc. Economics, we have growth, we have development, financing. So also to develop the nexus, we need financing. We need also, in terms of politics, privatization is important because now it's clearly everywhere PPP, public-private partnership, is important for many projects. The government or municipalities cannot fund a huge project, desalination project, for example. Environment, so there are some impacts on the ecosystem, also the climate change. So we need to take it into consideration when we look at this nexus. So as I said, so the nexus explains the links between water, food, energy, and human existence. Especially important in our region because we have this water scarcity. We have some issues also in terms of energy security and food as well. So we need to ensure synergies, trade-offs, and human resources issues are properly dealt with. Just to show you a clear list of water and energy, so we know that 80% of renewable energy comes from hydropower in general, so in many countries. So with dams, with hydropower, so we generate the biggest part of the renewable energy. Water is needed in power plants for cooling, and water is needed to clean PV panels, for example. So water, energy, and Nexus. The energy water, so energy, as we know, is needed in the whole water cycle to abstract, to produce, to distribute, to treat, to transport, to desalinate. So it's needed, and energy also is needed to pump irrigation water, etc. So that shows clearly the interlinkage between water and energy. So some figures or statistics: the water sector uses 4% of global electricity produced. In particular, for abstraction, 40%, conveyance, 25%, and treatment of wastewater, like 20%. Energy consumption in the water sector is expected to double from now through 2014 as a result of increasing seawater desalination. Right now, today, we are producing 100 million cubic meters per day of desalinated water, and this will increase and will double by 2014. Some challenges of the Nexus. So, for example, now we are promoting, we will get into having more and more, obviously, electrical vehicles. So some electrical vehicles, they use less petroleum, but producing their fuel gases more water. So, for example, here we show that ethanol vehicle, so the amount of water that we need, and for hydrogen fuel cell vehicle, for example, here 42 gallons. The plug-in hybrid electrical vehicle, 24 gallons, and gasoline vehicle needs only 7 to 14 gallons. So we need to be aware of this, because if we promote electrical vehicles, yes, also it shouldn't be also on the expense of water. So we need to think about also the issue of water, in particular in our countries. So how much water is required to generate 1 megawatt hour of electricity using gas? As you can see, like 7,000 to 20,000 gallons. If it's about coal and oil, we're talking about 20,000 to 50,000. If we look at nuclear, it's even more, 25,000 to 60,000. And what is the energy required to deliver 1 million gallons of clean water from? So lake or river, so fresh water or surface water, as 1,400 kilowatt hours. Groundwater, we need a little bit more, 1,800. And wastewater, we need 2,000 to 3,300. And for seawater, obviously, desalination, so we need even more, so 9,000 till 16,000. So the Nexus implementation, the Nexus has appeared first in Bonn conference in 2011. It's the first time that the Nexus as such was defined and was promoted. But still, in our our region, we have a style of thinking. So in terms of governance, because applying the Nexus requires also more coordination between different stakeholders. For example, the Ministry of Energy, Ministry of Water, Ministry of Agriculture. So we need more coordination between each other. Otherwise, obviously, we cannot implement this Nexus. So fragmented approaches arrive from inadequate management coordination among departments, ministries, and competition sometimes between urban and rural municipal government, etc., etc. So also we have the lack of communication. So the Nexus requires that all sectors have a common platform. I have been working for years, for example, to develop national water information system. Even the water sector itself alone, we don't have sometimes coordination, because the Ministry of Water have some data, the River Basin Agency have their own data, the Ministry of Environment have their own data, so sometimes there is a lack of coordination between departments and ministries. Unclear and existing interface between science and policymaking is important. Sometimes science is developed in universities, in research institute, but is not communicated to the stakeholder decision makers. So there is an issue there. So there is a lack between. There is a problem of communication between science and policy, or by science and industry. So I think these things are, for example, University of Mohammed VI, I think they are doing some effort to bridge the gap between, at least, for example, the research of science and industry. Decision makers don't have appropriate tools to analyze trade-offs. So decision maker at level of minister or directors, so they need to, they don't see the trade-offs. So they need, probably we need to help them with indicators, clear indicators to see the trade-offs, and adequately they can adopt a policy or another. Lack of data is a problem also. So we have sometimes lack of data. Sometimes there is data, but it's not harmonized. So different kind of data, different kind of indicators, etc. Technological challenges. So inefficient technologies and infrastructure in some cases. But nowadays in the region in general, we are on the top of innovation when it comes to desalination. So we have in Morocco, for example, the desalination plant in Agadir, it's by Megawatt. So we have the top companies developing different kind of technologies, wastewater treatment as well, solar and wind technologies. So obviously this will help promoting the Nexus. So technology development is important. So science input into the Nexus, you can see it in different areas. So in the desalination plants, in SCADA system to monitor, what's going on in the plants, solar desalination, wetlands, remote sensing, fiberglass pipe, etc., etc. Just want to give you some example, complete example of Nexus. For example, here in this example, in a city of this kind of configuration, 6 to 80% of a city's energy demand is used to produce treat transport water. So if we adopt the Nexus approach in this case, we will have this configuration. So we have distributed water and power, right mix, the right place, and the right price. You can see here, so each suburbs, they have their own treatment plant, so we take care of the Nexus in this way. So we have distributed water and power, and every city has its own, treatment plant, etc. Another example. So obviously, as you know, we need higher technology to treat and purify water. So which requires higher energy demand. In the case of desalination, whether membrane technology or thermal, we are talking about 30% to 40% of cost. Is coming from the energy. So if we apply the Nexus, so obviously we had many development in terms of technology. So if we compare the cost of desalination now with 20 years ago, there's a huge difference. So the cost of desalination has been decreasing, and now even we have the record of $0 to $28 per cubic meter in UAE. So the cost of water has been decreasing. The cost of traditional water supply may increase because obviously we need the water is getting deeper, and we need more energy to extract it, for example. So another example, declining reservoir levels reduce the hydro generating capacity. So sometimes when we have drought, like this year in Morocco, we have the level of dam decrease. So obviously we cannot generate enough energy. So if we apply the Nexus, so we reduce water consumption, we replenish the reservoir, we can use alternative energy sources like renewable energy, etc. Another example is energy exploitation and production generate large quantities of wastewater. For example, in Oman, when I've been there for 6 years, for each barrel of oil they extract we need 9 barrels of water, a huge quantity. So the first producer of water in Oman is PDO, the oil company. So what to do with it? Is water contaminated by heavy metals? It needs treatment. So it needs a lot of effort. They can treat like 175,000 cubic meters per day through constructed wetlands. It's a very nice project by Bauer, a German company, but it's still a huge amount of water is not treated. So it's a risk because if you inject it again, it will contaminate the groundwater. So the solution is we need advanced wastewater solutions, reduce water losses, and enable water reuse. In case, for example, some treated water, it could be used in irrigation, etc. So just to make clear, what is the Nexus? So desalination is a clear Nexus example because desalination is about water and energy. So we need energy to desalinate seawater or brackish water. So in our region, we have access to seawater. So desalination is a critical component of the solution. If you look at the water strategy in Morocco, Tunisia, Algeria, whatever our country, desalination is there. So it's not a unique solution, but it's part of the solution, part of the water supply solution. Also at a regional level. But the problem of desalination right now still costly sometimes, energy intensive, still consumes a lot of energy, and we have also the issue of technology reliance on fossil fuels. So not many plants powered by renewable energy. So this is still an issue. So we have also the impact due to intake and to discharge. The intake because when we put desalination plant somewhere, so there is an impact on the ecosystem there. And discharge is also even worse because if we dispose the brine into the sea, it may harm the marine ecosystem. So worldwide, as I said before, so we have like 100 million cubic meters per day produced. We have more than 20,000 plants worldwide. Half of the production is in the MENA region, the Arab region. And in terms of cost, as I mentioned it, so we are reaching 0.28 per cubic meter, which is really very competitive. And in terms of technology, RO is dominating the market, like 70%. The rest is thermal desalination. So for the upcoming years, RO will go even higher share in the international markets. So typical technology which is dominating the market now is RO. So as you know, RO system, so it's very, very known. So we have the pre-treated water. We need high pressure pump to push the water into the membrane. And then obviously we have post-treatment to adjust the quality depending or according to the use we need for drinking or whatever kind of use. And we have the brine discharge. So this is something to deal with. And we can take advantage of the discharge to use an energy recovery device to optimize the energy consumption into the process. So this is a simple way the RO system. So the RO plants in general so have this kind of processes. So we have the high pressure pump that we use, the membrane racks, the post treatment. We can see also the membranes. We can see the pumps, etc. So this kind of elements you can find it in any RO plant worldwide. The example is in Agadir, so it's a huge distillation plant. We are talking about 275,000 cubic meters per day. Half of it will be for agriculture. This is the first time that we have this capacity for agriculture. It's indirectly powered by CSP of water Z through high tension wires. Provide water for irrigation, drinking, ENSUS region. Alleviate pressure in the region's two major dams that we have there. 100% of rural areas in the area of Great Agadir will have access to desalination water. So this is a very interesting project, and it is managed by Megawatt, and it's a PPP project, public-private partnership project, in which private companies together with the government came together to develop this project. Another example in Jordan, Harbat al-Samra, which is a wastewater treatment plant. Very interesting example also because Jordan is the best students, let's say, in Arab region in terms of using treated wastewater. So this plant actually it's treats all the wastewater coming from Amman, and it's using renewable energy, and all the treated wastewater is reused. So this is very interesting example of treatment plants. So the Nexus, as I said before, so we need to evaluate and assess, evaluate the trade-off between different sectors in terms of energy production, the water use in all steps of the thermal energy value chain, the water storage for hydropower, the water for biofuels. In the primary production, agriculture, forestry, fisheries, we need to take into consideration. Industry and urbanization, the domestic use, industrial, wastewater treatment, desalination, tourism. And finally, environmental services, which include water quality management, biodiversity, flood and drought protection, navigation. What responses we have? So to respond justly to the water energy nexus challenges, we require increasing the recognition of socially defined goals for water, energy, food, and ecosystem outcomes, and increased recognition of the ecological rights, reduced use of markets as an allocation mechanism, like market values are not more important than ecological values, this is very important, increased use of reciprocity and redistributive policy to reach national and global ecological goals. To understand the Nexus, we need to calculate basic data. So there are models, there are people modeling the Nexus. We need data to demonstrate linkages, to identify key problem and risk, blah, blah, blah. Governing the Nexus, so we need institution, governance, policy response. So we need a committee, a sort of interministerial committee, something like that. Implementing the Nexus, guiding technical intervention to improve efficiency, effectiveness of the resource use, whether it is water, energy, or food. So primary production, the renewable-based water pumping, this is very popular. The use of renewable to pump water for agriculture. Renewables represent technically proven and cost-effective option for water pumping, but we need to pay attention because also when you encourage farmers to use solar energy to pump water, they keep pumping the water, and this could be an expense of groundwater. So we need to be careful sometimes. We can encourage renewables, but not at the expense of water. Distributed solar solutions can reach different types of farmers, smallholder, commercial, subsistence, through their diverse business and financial models. There are some financial models that are very successful in the region. Renewable energy in the Nexus, we can see in the what energy food Nexus, we can see the energy input with traction, electricity, mechanical, heat, cooling. So the primary production and the post-harvest and storage, the transport distribution of the food, either the processing of the food, either later in the retail or preparation and cooking, etc. Energy saving potential for drinking water supply. So we have a lot of potential to save energy. So drinking water supply, here's some figures from the Eurostat. We see the energy required for the drinking water supply, for desalination, for municipal use, for wastewater treatment, the share of energy, and the share of European Union of electricity is still very little. So we are talking about 1% in terms of drinking water supply, 0.67 desalination for municipal use. So it's very little share of the European Union electricity. The potential of saving energy in water supply and wastewater treatment could be achieved through energy efficiency and operational measures. So, for example, desalination, we use the energy recovery devices. The energy recovery devices have improved substantially in the last 20 years. So we have now more efficient energy recovery devices, for example. In terms of IO, for example, we are talking about 3.5 kilowatt hour per cubic meter, which is required for the IO process. But now we are even going even a bit lower to 2.5 kilowatt hour per cubic meter. So we are getting a little bit closer to the thermodynamic limit, which is about 1.1 kilowatt hour per cubic meter. This is from the Bureau of Reclamation in the US. They did an analysis of the energy bandwidth study, and they see where they can optimize and the different kinds of destination technology options in terms of end users, concentrate, etc. And they have very interesting figures. So they are pushing the limits to get a little bit closer to the thermodynamic limits. So the energy bandwidth, so we are talking about, as I say, 3.3 kilowatt hour per cubic meter. So we can reach 2.7 kilowatt per cubic meter. Obviously, the thermodynamic limit is 1.05 kilowatt hour per cubic meter. So we can a little bit get closer to 2 kilowatt hour per cubic meter in the upcoming years in view of the technology advances. Energy demand for water. So if you see the fresh water for we transport it for long distances, or seawater, RO, or brackish water groundwater desalination, or aquifer storage, so we have different kind of energy demand, kilowatt hour per kilogallon. So it's clear that obviously if we need to import water, it costs more, it needs more energy, so it costs more. Seawater still obviously costs more costly than other options. If we look at the energy demand for water in the Arab region, for example, in Jordanian water, oil sector accounts for 15% of the total annual electricity generated. In Saudi Arabia, groundwater pumping consumes 10% of total fuel consumption. In Libya, groundwater pumping costs a little bit around 14% of total fuel consumption. And Bahrain, 30% of the energy use is for desalination. Bahrain, obviously, all the water is from desalination, is coming from desalination. Energy saving potential for drinking water supply. So this already, I think we showed this figure. So in terms of energy efficient desalination, there is still margin to improve. We can improve in terms of electrical energy, in parts, in chemicals, in labor, but in membrane 6%, but almost electrical energy. So it's 56% right now, but we can improve this in the future. Likewise, in energy efficiency in wastewater treatment plants, so we have about 2 to 4% of the total electricity used in the United States, for example, the wastewater treatment plant. Their energy use is projected to increase. Obviously, as population increase and the regulation become more stringent. Energy efficiency has slowly crept into the water and the wastewater industry as the economic benefit has become more apparent, but there is still potential for significant improvement in this area. I can show you here the renewable energy in the Nexus, the different options, wind, offshore, PV, geothermal, CSP, etc. And you can see how much gallon per megawatt hour, different options. The innovation in the renewable energy technologies still it will have an important impact in the Nexus. So from the source, reservoir, lakes, rivers, etc. We pump water, or we desalinate, or treat water. The water heating, the end use could be agriculture, could be industry, residential, energy production, etc. So we have also the wastewater treatment. So it needs also energy, and also we need to deal with transpiration, evaporation also of the water in some areas. So green arrows indicate renewable energy. So there is different renewable energy options we can use for pumping water, for treating or desalinating water, or treating wastewater, or for water heating. Renewable desalination, so obviously we have many options. Renewable energy, we have so many options. The most popular, obviously, or most easy to apply, we have solar and wind. But still, I know that some plants are using wave energy, or some are trying tidal energy, which is a little bit complicated. The typical solutions that exist in the market now, we have the solar desalination. So obviously, as you know, renewable energy generation needs adjustment for continuous supply, and desalination technologies can adapt to variable operations. So either we have standalone configuration, we have an RO system with PV, and we have batteries from lights, or we can connect to the grid. So after the daily hours, so it can switch to the grid. So there are two different options. When we look at the technology readiness level, This is from MIT. So we can see that the successful combination is PV-RO, wind-RO, in terms of readiness, technology readiness level, in terms of maturity, in terms of cost. So solar desalination has many advantages. So we analyzed it in the references. We have many publications in this area, so we can see the share of the market. So we have more PV-RO, so 22%. 90% wind-RO, and then we have other options. So obviously, promoting solar desalination could reduce RO plant's carbon footprint, decrease the running cost, eliminate the link between water prices and the fuel cost. This is very important. About 22% of autonomous desalination systems are based on PV-powered RO units. Both solar energy and RO are mature technologies, so it's very mature in the market. This is some photo, the first photo from Oman. So we have an RO system with PV. So it's like 1.3 cubic meters per day. So we did it as a pilot to show the farmers how they can use the desalination with PV. In the north of Oman, we have like 100 farms using desalination. Some of them so with PV, some of them also they don't have solution for the brine. But anyway, we in the center we use it to bring them to the center to show them how it works, how they can find solutions to different problems. This is a photo from Tunisia, I think close to Madia. There is a desalination plant there with also with PV. Desalination even for agriculture is becoming popular in some areas worldwide, but it needs, in terms of cost, it needs many points to take into consideration. For example, in Almeria, Murcia in Spain is very popular, but they mix desalination water with other kinds of water, so to make it more affordable. And the problem that we have often is the environmental impact, the brine. So in the farms, some people have evaporation ponds. They pump the brine into, and they wait till it evaporates, and it takes time. So the concentrated salt is easy, to recycle. Some have more sophisticated technology like zero liquid discharge, or some companies are more and more interested in extracting the minerals from the brine. In Morocco, even this project, for example, is very old. We're talking about 2003, 2008. It's called Adira. I think it's a Megawatt project from the European Commission. At this time, we developed some autonomous desalination units in remote areas and not far from Marrakesh. And we had RO units powered by PV, producing like 5 cubic meters of water per day, which is enough for small population. And the cost at that time, we're talking about 3 to 6 euros per cubic meter. Obviously, it was obviously funded. But this project is 2008. Now, if we replicate this project, it will not cost that much. It will be a little bit cheaper. We have also similar in Tunisia. So since 2006, in Qasr Ghilan, so we have some similar systems. So RO with PV. It was also an interesting project. In Algeria, so we have, for example, solar-powered RO in the center of renewable energy I think in Algiers. So they have PV-RO, a nano-filtration system, which is a photovoltaic field that supplies electricity to desalination unit through DC-AC converter, and RO, or nano-filtration membrane for the water softening to enhance oil recovery application. So the range of the cost was 3.5 to 7 euros per cubic meter. We're talking about brackish water. Full-scale wind, these are in Spain. They have obviously many interesting projects. So in this case, they are powering the RO system with wind energy. The prototype designed and tested as a technical solution to water shortage in low water demand isolated areas. So it's very useful in remote areas with no electrical grid. So we don't have grid, so it's very practical solution. But we have batteries then if we can rely on the times of we need more energy. We have some interesting also examples. This is new ID. They use this kind of greenhouses. They use desalination to feed the crops with water. And so here is a clear example of water energy food nexus. And they have an interesting cooling system inside, and they grow the crops inside the greenhouse. Because obviously the Gulf countries, they have a very high temperature in summer, so they need this kind of solutions to grow crops. So are we talking about innovation scientific deficits? Without water stress, without food shortage, without energy shortage, institutions and technologies evolve slowly. So obviously we have a need. So we have a need. So obviously technology is advancing everywhere. In the absence also of regulatory pressure and public funding, change is low. So also we need regulations. Otherwise, things will not move fast. The same, we need funding obviously for such a project. And disruption by new technology is low due to large sunk costs in existing systems. Sometimes obviously the cost of new technology is very consequent and we cannot afford it sometimes. So decision-making tools with Nexus perspective. So if we can define a sort of framework, comprehensive of the analysis of the Nexus impact of energy policy. So we have the traditional side of policy making, where the decision-makers take politics, top-down approach. Then we have preliminary assessment of the Nexus impact of policies, and then we can go to a fully integrated assessment of the Nexus impact of policies. So this is the approach if we can advance, change from silo policy making to Nexus policies. Key consideration. So probably I mentioned already data. So we need obviously data to model and know exactly what we need. Limitation of analysis and tools. Sometimes data, problem accessibility, availability, scale, time series, blah blah blah. Resources also financial time. In terms of what's the starting point, so energy system level analysis on water and food is very necessary, but with practical output that can inform decision making. We need to integrate water land constraint into existing energy models, and we need to break down the ministerial barriers to truly tap into the win-win opportunities. So we need to find win-win opportunities in order to advance in this area. So from science to policy, societies and academic researchers need to communicate with decision maker, and the decision maker need to include scientists and create dialogue. Decision makers like numbers, so you need to show them the numbers, how much money you will save if you use this next approach here or there. So scientists need to be quantitative and provide clear indicators in the policy making process. Both stakeholders need to be evidence-based and create a synergy for data generation and sharing and analysis. Also, we need to build on current structures, scenarios, rather than a substitution approach. Governance solution, I mentioned already. PPP financial mechanism is important to fund this kind of project, and capacity building is important. So we need to train people, the ministries and everywhere, in order to understand the implication of the Nexus and the funding financial resources, etc. So we need multi-project approach. So demand side management and the supply side management. So in terms of reinforcing institutions to support a move toward efficient resource use, support policies that rationalize demand for water and energy services. We need to support investment in efficiency improvement. The supply side, we can introduce and scale up technologies like desalination, reuse, etc. Support innovations in renewable energy, like now we are talking all about green hydrogen. Support innovation in concentrated management, brine, and support water quality protection and storage capacity, including aquifer recharge, etc. Some remarks for the implementation. So as I said, we need management, governance, multi or cross sectors. We need resource use efficiency and greater policy coherence between different ministries and the stakeholders. We need innovative and affordable local actions, so that could have impact on the social, economic, and environmental sides. Integrated destination with renewable power, this is very demanded now. And we have some examples. So we have Sahara Wind Energy Project in Morocco, renewable energy for wastewater treatment and reclaiming water use in agriculture in Jordan. We have solar desalination, many examples in Morocco and Tunisia, etc. So these case studies demonstrate the potential of the Nexus and the benefits, so we need to encourage them. We have many examples, Regen, Minaret, Prima, so we have now Prima Foundation is funding Nexus project, and in every beginning of the year they launch a call. It's very interesting for researchers here and everywhere. Political commitment and scientific backing are key, and the Nexus obviously will facilitate better integration of scientific data and policy considerations. So all the countries actually, they have commitments vis-a-vis Paris Agreement, vis-a-vis national strategies. So sometimes we need to unify, the reporting process. We collect the data once, and we use it for multiple purposes. So this is the key. So the perspective. So obviously now we're talking about green hydrogen, the green hydrogen economy in the future. We have now national strategies in Morocco, the European Union, Germany, the European, and pushing to, they are willing like 40 gigawatt green hydrogen from the MENA region by 2015. So this is huge. Obviously, green hydrogen now, the cost is still high. There are some challenges. So we need, for each kilogram of green hydrogen, we need 9 liters of high quality water. This is huge. It's in particular in our region, we have water scarcity situation. Obviously, the only solution is desalination. But people are saying it's costly, etc. But if you calculate the cost of desalination, the process of the whole cost of the green hydrogen production is a little part of the whole cost. But obviously, it's something that we need to discuss, and we're talking already about what's a hydrogen nexus. So we need to produce green hydrogen probably in the future, but not on the expense of water. We need to find solutions. Probably the technology we can have advances. Maybe we can use different kind of less quality water. So this may solve the problem. So we cannot tap on the drinking water, which is scarce. Yeah. So in terms of recommendations, so I personally encourage collaborative, focused R&D, the Nexus by forming regional research teams, alliances or promote innovation, technology transfer. So there is a way to connect energy and water research groups. We can develop things together. We need to scale up the technology, replicate, and fund ongoing projects related to the Nexus. We have some examples, so we can maybe replicate some success stories. Whether it's about integrated seawater energy, agriculture system, whether about renewable energy for wastewater treatment and reuse, or solar desalination, etc. We need to support and provide incentives for strategic partnership, cooperation between the research center and private sector. This is very important. Private sector, I mean, in particular industry. Build capacity for policymakers. So we need policymakers are not really necessarily aware of this kind of approaches. So we need to boost the regional knowledge management systems. The Nexus is not mystery and not a solution, obviously, but it will improve the coordination across sectors which is part of the equation, and action lies in detailed intelligence to support decision making. Obviously, we need to accelerate energy transition. In Morocco, we have very ambitious targets. We have like by 2025, we need to have 52% of share of the renewable in the share of the mix of energy. So we need to increase the share of renewable energy, in particular for water sector, desalination, reuse. And finally, we need to consider, as I say, the water hydrogen nexus from now. And this is a trendy area that requires deeper R&D efforts, in particular in Morocco for the other MENA countries, obviously. So I don't know, it was probably very fast, but I hope that it was somehow understood. So I will be happy to respond to any questions. Thank you very much.
Thank you. So thank you very much, Dr. Kharet, for this comprehensive and very inspiring talk. Particularly, I think it makes you aware of the dimension of the Nexus, and that is multidisciplinary, but also dimensional kind of problem. So to discuss this, we have Dr. Kharet, and we have a panel that I would like to invite to join this table. So I think I will start with the obvious question, which is related to policy, industry, and research. How, in your opinion, how healthy is this relationship today, and how could we make it better? So can we start with that?
Yeah. Sure. Yeah, thank you very much, Dr. Yunus, for this question. Probably I mentioned during the lecture this issue. I mean, an example in Oman, recently they created a platform where it's a partnership between industry and the research institute and the universities. So they ask industry to be the platform, to be paid membership fees per year, and they post all the challenges, the industrial challenges or problems. And then the universities and the research institute on the other side, they have access to these kind of challenges. And if they have a solution, they can submit it through this platform, and then there is a committee in this platform which evaluates if the solution is promising. And then once it's there, they connect the industry with the research team to probably send the contract and go ahead. So this is just an example of how can we connect, for example, the research or academia with the industry. So definitely we need to fill this gap and connect them. This platform is just one example of possible solutions. So we need more connection between research and industry. Obviously, policymaker is the same. So me, I had the chance. I was a pure researcher when I was in Spain as a PhD student, and then when I moved to France, sort of international organization, so I started working with policymakers, ministries of water, etc. So I realized how important it is to connect with the policymakers what we do at scientific level. So sometimes we are in the research academia, we are in a hurry to publish more papers to increase our index, etc. But sometimes also it's not less important to connect to go to the areas of policymakers. So, for example, to contribute to drafting the strategies, the policies, and because many times even policymakers they go to scientists to, for example, the clear example is the Paris Agreement. So this IPCC, which is a group of scientists worldwide who contribute and they show science evidence of where we are from the objective of 1.5 degrees Celsius by 2100. So I think that just quickly to respond to the question. So we need obviously more connection between the research and industry with the policymakers, and this could be made by annual forum where we can invite the minister, invite the decision maker, the industry, and the research. So this can present the latest output of its research, and then we can hear from the policymaker. And this kind of forums or dialogue is very useful to make sure that your research is understood by the science, by the policymaker, and the policymaker know what you are doing.
Excellent, thank you very much. So I'd like to go to Dr. Shekner. You as a researcher at a university, how do you see this question? And when you make like when you do research, you have a lot of multi-choice of subjects that you might choose for your research. Do you make these kind of considerations, and how do you go about choosing your research subjects to make sure that the bridge is actually built?
Thanks, Professor, for this opportunity and for bringing Dr. Jaleb to share his thoughts and his perspectives on water energy Nexus. It was really a pleasure to have you on for this. Replying to the question, Professor, well, actually, it's quite delicate, as we all know, because at some point when when we talk about high-level research, it needs money to keep things to start and to keep things going. And at some point, we have to get in touch with the funding bodies and most importantly, industrialists. So at some point, it's inevitable. We'll have to make this contact. And whether we like it or not, they're going to have an impact. For the good or for the bad, but they're going to have an impact. And for us, I think it's we're in a good position to, from my debugging perspective, meaning that we do have the key for the industrials, for entity that wants a solution to be provided in the water energy Nexus. But we do have the key for this innovation, either to lower the cost, to make the process much more efficient. So if we we put ourselves and we convince ourselves that we're in much better position, I think we can have big leverage and get hold of the research that we want to pursue. And related to the question asked to Dr. Kharaz, is very important also to have this multi-part approach to research. For us, it's much more comfortable. I think that colleagues will agree is to secure fund, to hire postdocs and PhDs, work, get your published paper in Q1 journals, and then the whole circle again. But at a certain point, I think this is one of the the interesting perspective given here at the university is that we have this luxury to have hand in hand with the industrialists and then try to develop something for him, but also later for Morocco and for Africa. And I think that it's a winning strategy that you put it in your perspective, and we need to push more into this.
Excellent, thank you very much. I go over to Dr. Mahad. So understanding from the speech of Dr. Kharaz that Nexus is a multidisciplinary area of research, multidimensional area of research, as somebody who works on materials for energy, where do you see your contribution as a material scientist? Where do you see materials science? Where should it go in terms of similar question to Dr. Shakir, in terms of choice of subjects? Because as he also mentioned, it's very expensive to do research these days, and you have to be very clear about the kind of research you want to do that is impactful, it has a clear impact. So where do you see materials research in this subject going, and how are you going to achieve your objectives in the subject?
Yeah, thank you, James, for the question, and thank you, Dr. Khalas, for here and stating talk about what makes this complicated relation between water and energy, and also food. So what we can as researchers, I think to answer to the needs, industrial needs, and the society also to have the impact to go to as researchers. So yes, we prepare to make articles and publish lots of articles, and so that also we need to answer to the needs, and also to bring this trust, especially in Morocco and our region, Africa, so to have trust between university researcher and industry. So sometimes in the research, we can see some technology is far from the reality. Like if we see the presentation, so no way for reverse osmosis for us as a practical water treatment. So we need to develop membranes and so on for this technology. But in another side, we have also another technology like CDI and capacity utilization and so on. We are working in this technology. Yes, it's a little bit costly, but yes, why not? So let's to see if can bring some solution, and also for small communities, because reverse osmosis, so this is upskilling for big plants and so on. But we need also to see some small devices can allow people to have drink water in very easy access and low cost, and so on. As discussed this one. So that is I think that's what I think.
Thank you. Thank you very much, Mike. So I go back to the questions. Does that mean, I mean, listening to the colleagues there, does that mean that developing solutions or developing research in the water energy nexus area necessitates mega programs with the implication of countries and bigger organizations, or is it possible to actually have an impact at a much smaller level?
Yeah, thank you very much for this question. Very interesting. I mean, when I was in Oman, in Medrek, Middle East Destination Research Center, it's an international organization. It was created 12 years ago, and the problem is that when we set to the strategy, which again we are not going to compete with cost or with Mazda. We have few resources. We don't have that much $1 billion to develop, let's say, innovative technologies. But we thought that we can do with some actions and impact. For example, one of the things that we did, we discussed with USAID and with the highest politicians in Oman, and we got into a very interesting challenge. We call it Oman Humanitarian Destination Challenge. This challenge is about $700,000, which is still, still on. If anyone here has a solution, it's still on. $700,000 to be given to whoever in the world could develop small destination device that could be deployed in areas of humanitarian crisis. For example, if we have somewhere tsunami or earthquake or floods, whatever, and then the water system is broken, so people don't have water, so we can easily, with helicopter or whatever, we can throw these small devices and people can survive. So, and in parallel, we launched a research path where we can give $90,000 to research teams who can develop a little bit, let's say beta version probably of the solution, like 120 liters per day solution. But what I said, challenge, for example, this kind of challenge is one option where we can stimulate innovation and we can do international impact. So now people all around who know Medrek, they know this challenge what we do. And then obviously we cannot minimize the impact of some small research project. some research project where we can develop a solution, or you have a patent. Later on, can bring you bigger projects. So you cannot also how to say desestimate small project, because sometimes they can bring you big fish, as we call. I don't know if you answered the question.
Yes, thank you very much, and I think it gives hope your answer. So I think you heard him correctly. There is a $700,000 for you students.
I can tell you website, desalinationchallenge.com.
Desalinationchallenge.com. Right? Go there and apply with your Okay, very good. So that means that I'm pretty happy with the answers. Do we have any questions from the audience? Also online, I think we have about 100 people online that are listening to this lecture. So please feel free to ask a question. Anybody?
Okay, I just want to refer to the slide 76. Wonderful presentation anyway. And go to slide 76.
Which
slide? 76.
I'm sorry.
Okay, so yeah, Doctor, thank you so much for the extensive research on this wonderful presentation. I just, from a layman's point of view, when you look at this, this slide particularly, the essence is for us to have hydrogen at the end of the day for industrial processes. Here you're introducing water, and then you're getting oxygen out, having hydrogen, and then you're introducing hydrogen again to get the hydrogen for industrial, and then you're using the hydrogen for fuel cell, and then you're introducing oxygen again for the hydrogen to get water. Just from a layman point of view. You know, in science, when we want something, we introduce the same thing to get that thing. So I just want explanation on this. Thank you.
Thank you. Thank you. Thank you for the comment. So as you say, as scientists, we need, as each time we need to find something. We produce a solution, and then from the solution we can provide another solution. So,
Next.
Okay, thank you very much, Doc, and then Prof. Thanks for giving an opportunity to listen to this. My concern is, thank you very much, fantastic presentation. My major concern is how do we get the public sector policymakers in this platform? Because we need a lot of investment for you to drive this, and even the effort towards going to greener energy. You need huge investment, and this investment are not forthcoming. I can understand the private sector, yeah, they can take that decision. Of course, the academia are also, supporting it. But the public sector's policymakers, they need to be on this platform for an inclusive policy that can create a conducive environment for investment. So I don't know what strategy we're going to do to get that.
yeah, if I go through you will, you are wondering, if we need to involve policymakers in the process, we need investments.
Mechanisms.
What's
the mechanisms?
The mechanism, yeah. So it depends on each country. So the governance of each country. Some countries are very successful in making together policymakers and research and investment. For example, when I mentioned the PPP mechanism, which is very now successful in big projects like dams, highway, desalination plants. So we bring together private companies and governments to develop this kind of project, because it's very costly, more than $100 million per project. So this is very costly. So we need at developed countries regulation that encourages investments. We need incentives sometimes also to investment, to encourage the investment to the private companies to invest in, for example, renewable or in water and whatever. So incentives, regulation. We need also strategy. So in general, countries at the tax sector have a clear strategy where they know how they're going to involve the private sector, which kind of project they are going to give them. They need to show the private company that there is a win-win situation. They can get a return of their investment. On the other side, they give the services. So this was, I can say, spontaneously on your question. So even in Morocco, for example, we have, I mentioned, Agadir plant, very successful PPP project. So it's now operational since 2-3 months ago. And I think it's valid for many infrastructure projects. So PPP, we have many mechanisms like BOT, BOO, depending on the type of project. But it seems that quite successful in this kind of project.
Thanks, Mr. Jawad, for a nice talk. Nice topic, and we will there is more opportunity to work. So you presented the water desalination as the main technology that can address this water energy ENSUS challenge. So what about other water treatment technologies such as adsorption?
Yeah, thank you for the question. Actually, to find solutions to water problems, we need integrated water resource management. So it means that we need to care about the demand and supply, not only supply. So desalination is just an option. Desalination, adsorption, many other kind of treatment technologies are options. So we need first, for example, we have a lot of water loss in agriculture. The efficiency in agriculture is very low. We're talking about 50%, so it's very low. So a lot of things to be done in terms of decreasing the water loss in agriculture. So agriculture in the Mediterranean, Morocco, is almost 80% of water resources. So this is huge. Then, for example, we have a lot of water loss in distribution networks. So we need what we call no-revenue water. Also, no-revenue water is very high in the region, like 30, sometimes 40%, they're huge. So a lot of water is lost there. So obviously we need technology, sensors, we need SCADA system, etc., to detect the leakage immediately and stop it. So and then also, this is about that, we need also water pricing. We need also to choose the right policy, water pricing, in a way that we don't condemn the citizen. At the same time, we show him that if he goes over the conception, he will pay the double or triple. So this kind of pricing is very interesting. Legislation as well sometimes. So obviously some people, industry, they are using water, groundwater, sometimes without permission, etc. Then we go to supply. So we have surface water, we have groundwater. Then we have different kind of no conventional water resources. So you have the reuse treated water, and water treatment, desalination, but not only the option, as you mentioned, absorption, depending on the situation, depending on the quality of the water that we want to treat, depending on the use we want to give this water, drinking or agriculture, etc. So I don't know if I answered your question, but again, this kind of desalination, etc., they are not the solution, they are part of the solution.
Thank you, Mr. Khalis, for this talk, interesting subject. My question is, as you know, that in general there are two types of water disparity in physical and economic. My question is, can the desalination technique definitely solve the water scarcity issues in the MENA country?
Yeah, thank you for the question. It's clear. I mean, I mentioned the example of Egypt. Egypt are relying 90% of the Nile River. So now with this kind of with the dam of Renaissance, so they went directly to desalination. So many projects in the pipeline, the Red Sea shore, the Mediterranean shore, in the Gulf relying almost wholly on desalination. In Morocco, so we are talking about desalination plants, in huge one in Casablanca, I think 300 million cubic meters per year. We are talking about Nador or Hoceima plants. So we have many projects in the region. So desalination now becoming the solution, in particular because the cost is becoming competitive, less and less costly, and because desalination allow you to have immediately big amounts of water. While other solutions, it's all this kind of water demand. I mentioned water demand measures take time. So awareness to aware the citizen to not waste water, improving water use efficiency, water use productivity, agriculture. So that this takes time to get results. But desalination is a quick solution, and there are private companies that they want to invest, so they easily can mobilize it and build your plants. But that said, obviously we need to be careful. So the regulation should be strict in terms of disposal. So if the companies have no regulation, they can dispose the brine as it is in the sea. It will be very harmful to the marine ecosystem. So it should be a strict regulation. Should be maybe some regulation that oblige companies to pre-treat the brine before disposal or find solution, etc. So we can encourage desalination because, as I said, it's a huge solution, but we need also to deal with environmental impact and make sure that we have solution and we are not harming the ecosystem. I remember 3 or 4 years ago, we received a delegation from Senegal. They wanted to build the first desalination plant close to Dakar. And what I appreciated is that they came a huge delegation. The company which is going to build the desalination plant, the mayor of the city, the environmental association, and the fishermen association. The fishermen were very worried about desalination plants. They're going to have desalination plant very close, and they will, their activity will be affected. So I hope that they will, develop something that will not be harmful to the environment. But I appreciated the participatory approach. So people, all the interested parties are coming to discuss the project, to ask us how much it would harm this their activity, etc. Thank you.
First of all, I would like to thank you for attending the presentation. Thank you very much. Then I would like to ask about if we can see the distillation in terms of the environmental side, like it is dangerous for fish or something like that.
If I got you well, you are talking about the environmental impact of the distillation. Yeah. So right now there are solutions. So a lot of companies worldwide, they are extracting minerals from the brine. So they are valorizing the brine. So they are not making it directly disposed to the sea. There are, as I said before, small areas for farmers, for example, they have evaporation ponds. It's a very basic solution, but sometimes it's for small production, it's useful. So, but you need to respect certain design. I mean, it should have a slope, etc., in order to optimize the evaporation. I remember once I visited one farmer in Oman, and the guy has an evaporation pond like that, very deep, and the brine is there for ages. So I mean, obviously, and then he ended up by re-injecting the brine into the aquifer. So this is very, very, very bad. So environmental solutions, the solution for environmental impact exists. Even for the desalination plant, the construction where to build the plant, obviously it needs a prior environmental impact assessment study. So we choose the right area, not far from the areas where the eggs of fish or lots of fish. And also in terms of the intake system, it needs to be carefully put in the right place. The disposal also should be another pipe in a way that also we use dissipator. So we dissipate the brine, so we avoid to have a high concentration of salt on the brine area, so we dissipate. And yeah, so we have many solutions. But as I said, to enforce the solution, we need to improve the regulation, oblige the policymakers to make obligation on the companies to respect the environment. Otherwise, the company can do, they want to win. So they want to earn more money, and they don't sometimes care about what's going to happen to the environment. Thank you.
Thanks, Raz, for this presentation. So my question is in the field of hydrogen export. So we know hydrogen export is very expensive. So like Qatar need to transform to liquid state and export. So my question is, did you interested about found the easy way to export hydrogen and cheap ways to export hydrogen?
Yeah, thank you very much for the question. As I said before, so there's a lot of interest now. Lots of Morocco, we have the roadmap of green hydrogen. The cost is still high, so technology. I'm sure that in the upcoming years we will have improvement in technology, so we may have low cost. Morocco have the advantage of the infrastructure of the gas coming from Algeria, so now we own it, so we can use it eventually for this exportation of green hydrogen to Europe, to Spain. And as you said, so yeah, we need to convert it to liquid, then to facilitate to export it, transport the green hydrogen. Now, if we look at the Gulf countries, they are more looking for blue hydrogen because it's cheaper and it's it wants a little bit of time to switch to green hydrogen. It depends on the country. So Morocco, I think we have the renewable energy, so we have the potential. We have also, even the derivatives of green hydrogen, we talk about ammonia. So we are the first producer, first exporter of phosphates in the world. So we can, have big potential. For ammonia, for example, industry. So yes, I believe that we are much advanced stage than other Arab countries in this area. That's why Germany in particular are very interested in Morocco, and they signed many agreements with ENSUS, with the governments. So Morocco, I think they say Morocco, Egypt, and Oman, they're the most Arab countries ready for this green hydrogen future exploitation.
Thank you. So I'm going to take 3 more questions, and then I'd like Anna to project the magazine. So there's an article by Dr. Celeste that you can read where some of these issues are, and then you can also send your questions to ENSUS@gfcc.com if you have any other questions, and they will be treated. Okay, but to make sure that stay in time, we have a question here, and then we will get there.
First of all, thank you, Professor Celeste, for the very nice and illustrative presentation. I have 2 questions regarding to materials. So the first one is, I have a question, like the desalination process, is this the same like in Oman or Egypt and also in Morocco? Like, what's the characteristics that this plant can work in a country? Is there the characteristic of water or other things? Also, I have a question regarding the membranes. Like, if we have a kind of type of membrane that we developed in our laboratory, there is any possibility to test it in a prototype or plant in your institute. Also, the second question, as a person working on corrosion, like there is more. I'm asking, there is more challenge to see corrosion on those desalination plants? Thank you.
Thank you very much for the very interesting questions. Yeah, I mean, obviously the technology is the same, whether RO or capacity utilization or membrane distillation or thermal distillation. So it's the same technology. Obviously, should be adjusted. We have different pre-treatment system. We may have different kind of energy recovery devices. We can have different pump. We can have different high pressure pump. So sometimes optimization is done. For example, I mean, Veolia is having a lot of plants in the Gulf area, for example. And if you look at the plants of Veolia of years ago, and obviously it's not the same as the plants of Veolia last year. So there is a lot of advances every year, and they optimize in order to decrease the cost. So obviously technology is the same with RO or other, but it adjusted. Obviously the quality of water, all these factors are important to adjust. So adjust the kind of membrane, the kind of pretreatment with multimedia filter or cartridge filter, etc. We adjust the different also configuration of the membrane, etc. Lots of optimization could be done in a way to reduce the cost. This is one. Second one was about, if I remember well, the membrane. Yes, membrane. Yeah, this is an area where I mean very researchy area. So lots of laboratories in the world are, I mean, because there is margin to improve the efficiency of the membranes. So we can do better. So definitely. So I know many research groups around the world are developing better membranes or other. We have, for example, in Autónoma de Madrid, Mohamed Al-Khayat, Moroccan researcher, who is very good in membrane distillation, and he is fabricating membranes for membrane distillation technology. And there are others are talking about graphene potential. 2018, the researcher from the University of Manchester published in Nature that graphene membrane will make a revolution in technology industry. But since now, we didn't see anything. It's not true, but the problem is that from laboratory, from research to the industry, years. So it's a big challenge. So when the publication appeared, many people started talking about graphene membrane, but right now I don't see any graphene membrane at industrial level. At research level, there are people working on it. So I encourage you, obviously, membrane, there are many things could be done, especially we have raw material here close, and we can have very interesting membrane. And I saw this morning, thanks to Dr. Muad, who showed me the laboratories, you have equipment to make very interesting research on the membrane application. In terms of corrosion, etc., obviously, RO disadvantage is this. I mean, membranes are suffering from the quality of water, from the use. I mean, obviously, membrane have less and less lifespan, and that's why we need to improve the kind of membrane. In the Gulf area, for example, they have even worse problems. They have what we call harmful algal blooms, HABs. So lots of algae, when they have a lot of concentration, they either get into the intake system, they block it, or if they go into the plants, they obviously have a lot of problem in the membrane. We need to change the membranes. We need to increase the operational cost. So the choice of membrane also the way you operate and you maintain the plant is very important. If you are not trained well to do this, obviously you will have this kind of corrosion often, and many fouling and scaling, etc. And even maybe I have here a friend from Oman, Mu'tasim, who is now researching at the university, who worked with me in the destination field. We have a very interesting project where Mu'tasim developed some work. We try to recycle the RO membrane to reuse them for other uses, like treated wastewater. As you know, RO membrane, after 5 years or 8 years, depending, even less sometimes, have a certain life cycle, and then we dispose in the landfill. So we propose solutions, and instead of disposing in the landfill, we can do some, measures to convert it from RO to nanofiltration or ultrafiltration or microfiltration membrane that could be used elsewhere. So, and also another factor in Oman, for example, in Oman, all the plants, the life cycle of the membrane is the same, more or less, 5 years, 6 years. In one plant, in Sur, it didn't change the membrane never, because the intake system is very interesting. It's a beach well intake system. It's from the beach and they go into the sea. So there is no algae, so the quality of water is very good. So they don't have to change the membrane, at least for the time being. I hope that I responded to your question. Thank you.
Thank you, Mr. Khalas, for your clear presentation. My first question is about how can the desalination project be carried out successfully, especially in rural areas.
Yeah, thank you very much. As I said, in rural areas, even 15 years ago, many projects were successful. So remote areas where we don't have necessarily grid sometimes. So with even PV, with windmills, so it could work perfectly, and the cost is becoming competitive. So right now, I see, it's very easy. Oman, for example, many farmers they have. I saw in Tunisia, Mahdia, Morocco, the area of Morocco, some people, I'm not sure it's still, the problem with the project sometimes, once the project ends, nothing happens. So there is no sustainability sometimes. But if there is sustainability, people can maintain the plant. It will perfectly work, depending on the use, how much water you need. So you can adjust, your unit and all to your usage, your need, and could be work perfectly. So I think it's becoming more and more competitive, and it's it's very much a technology. So it's easy. There are companies that can sell you the huge unit with its PV and they deliver it to you, and you can run it from the first day. So, yeah.
We have a question. Okay. Thank you for the presentation. My question is, I always get puzzled when we talk about water security, water scarcity in the world, since more than 70% of the Earth's surface is covered with water, like 2/3 of the Earth is water. So I believe what causes this scarcity, maybe climate change, mismanagement, overconsumption, maybe growing demand. So for climate change, I know the world is doing a lot in order to solve that. So are there any other frameworks, like global frameworks for the other challenges that causes the water scarcity? Because I think we shouldn't be having water scarcity since we have abundant water resources in the world.
You're totally right. Obviously, the problem is an accumulation of factors. Obviously, climate change is impacting. We have more and more drought seasons. We have less rainfall, and we have obviously population growth. But also, I think one of the main factors is the mismanagement of water. So obviously, we are polluting water, we are overexploiting aquifers and groundwater, and a lot of water is lost in either in distribution network or in agriculture. So it's more mismanagement, definitely, because either with this water scarcity situation, and some countries in the region can do better. So there is a lot of budget to improve. For example, in the negotiation between Egypt and Ethiopia, obviously Egypt has the rights, based on the agreements of the United Kingdom from the 2020 of the last century. But Ethiopia said, you have, no, Egyptian said to Egypt, you have other water. You don't have. We rely only on Nile River. Why Ethiopia? They have other resources. They have rivers. They have other things. But again, it's difficult. What we call water diplomacy. Water diplomacy is when we negotiate on our right on water using water diplomacy tools. Sometimes there are successful stories, like in Brazil. We have a dam, water shared between Brazil, Uruguay, I think, and Argentina, I think. They are sharing water, and they have a dam, and they distribute the water and the electricity generated by the dam. The same in Senegal. So there is Senegal, Mali, I think, and the 3 countries around the Senegal River. The same agreement. So they use the water diplomacy tools in a way to have win-win situation. So we can get water, we can distribute energy. So we don't have only water, energy. We have maybe knowledge, cultural knowledge, or train you, etc. So these kind of things. But to return to your question, yes, not only climate change, not only population growth, economic growth, also risk management from the people, citizen, from citizen to the decision maker, and obviously industry also. If they pollute water resources without any kind of fines or regulation, obviously. So risk management is a big factor.
Thank you very much, Dr. Jerez. I know I said that was the last 3 questions, but there are 2 more questions that people have. And once again, so if you have any questions, please send to ENSUS@gmp3.ma. I promise you will get such a question from one of our experts in the panel, Dr. Jerez. Okay. So, before that.
First of all, I would like to thank you for this informative presentation. Yes, my question is, how can the transition from fossil fuel to renewable energy affect the relationship between energy, water, and food?
Between energy and?
Water and food.
Yeah. Thank you very much. Very interesting question. Obviously, if we push towards implementing this Nexus, obviously, and also pushing for the commitment vis-a-vis the green transition. So, as they say, Morocco, we have this target of 52% renewable in the share of the mix of energy by 2035. In Egypt, we have like 42% by 2035. So we have very ambitious targets. And so obviously, the way to accelerate is obviously incentives, encouraging investments in the renewables, encouraging renewable destination, for example, renewable destination. We have also another commitment, which is Paris Agreement. So we need to mitigate, we need to adapt. So obviously, all these kind of commitments will make us get into the road towards green transition. So and also there are some other factors. We are very reliant on Europe in terms of economic protection, etc. Products. If they adopt the carbon, for example, tax, we will definitely need to prepare for it, because one day we will hear that we cannot export our products. So it's a problem. So obviously, we like or we don't like, we need to adapt ourselves to the environment. So Europe around, so we need to adapt our economy. So the green transition is well. So we are going probably well in the energy, renewable energy, a little bit less in energy efficiency. I think we need to do more effort in energy efficiency. And all this move of green hydrogen, etc. Also, I think in the same road. So we are going into the same road towards achieving the green transition, the SDGs in 2030, and the Paris Agreement, Paris commitment.
Thank you.
Yes. Thank you, Dr. Jerez, for your fantastic presentation. So I have a general question basically about water, food, and energy economics. So if we talk about the desalinated water for use in agriculture, so how will be the perspective in the future to feed a huge population? What could be the effect of this cost on the final price of the food?
Yeah. Thank you very much for the question. Obviously, desalination is economic, so the cost is essential. Sometimes, obviously, if it is a water security issue, a national issue, so we can afford to pay more to get our security. Obviously, water is impacting food. That's why we talk about in the past virtual water or water footprint. For example, if you cultivate crops that consume a lot of water and you are exporting it, you are exporting not only the crop, you are exporting also the water. So sometimes, is it worth to import this product instead of cultivating inside and wasting the water? Yeah. But it's not that easy sometimes. You know, even if you consider this, you need to talk to farmers. So sometimes farmers are not really necessarily to change their crops, and a lot of factors to be taken into consideration. But definitely, we need to take into consideration. In the COVID, for example, the first month of the COVID, when China closed the doors, I remember a friend who is managing this plant in Oman. He told me this is, if the closure continue for a longer time, it's a problem. Because we are importing everything from the China, all the membranes, the chemicals, everything. So it's a huge issue for the security. Now Europeans are realizing that we don't need to follow our companies. They are looking for low cost in the localization in China or wherever. So in some product we need to localize and have our own. So this is to take into consideration. And the same for agriculture. In Spain, it seems successful, success story. In Almeria and Murcia, a success story. In Oman, it's not that much because in the beginning, the government subsidized the farmers to use, desalination even with PV, and then they removed the subsidize, and it's becoming more expensive for the farmers. And especially, desalination in dessalation in Oman is more costly than in Spain. As I say, in Spain, you have some techniques. They mix the desalination water with other kind of water, so you have techniques to make it, less costly. But with the future, with the food security, food crisis, definitely desalination is there because whatever it costs, which it comes to food security, we can afford to pay more to get it. So I think desalination agriculture will become more and more popular, definitely.
Yeah. Thank you very much.
Okay.
Okay, thank you very much, Dr. Perez. Big hand of applause, please. So, does the panel have any more comments or anything that you want to add to this?
Just one thing, so thank you for the questions. I actually had questions because the water Nexus energy is our problem, as it turns for the future. So as Necessitates, we need to keep in mind and also to think how I can solve the problem. I can even that can be origin problem inside of the electrolyzer or any tools for. So as Necessitates, so we need to think how I can bring the solution, how I can impact positively the technology or solve or be part of the solution in the problem. So that is my comment. Thank you.
Okay, so again, thank you very much, Dr. Khaled. Thank you very much, Dr. Shakir and Maad. And thank you also very much for being here and for your engagement and your interaction. That was very good. Please do not forget to send your questions if you have any. I promise you we get some answers. And do not forget that in the first issue of the ENSUS magazine, we have a special interview with Dr. Khaled, and we also have a water, energy, food Nexus article by Dr. Afrin. So go and check it out. And thank you again. Have a nice day.